topic is solving systems of linear inequalities. Suppose that you are told that x minus y is bigger than 2 and that y is less than negative 2x plus 3. So we want to graph each of these separately. To graph the first one, first we should graph x minus y equals 2. Basically, you just need to understand what this is saying. You should pick x and y so that when you subtract them, you rarely get 2. 5 minus 3 is 2. 3 minus 1 is 2. 2 minus 0 is 2. X minus y is 2. Oh, there it is. So let us plot these points. 1, 2, 3, 4, 5. Put some positive y's, some negative x's, etc. When x is 5, y is 3. So I go up 3. There's 3 across. When x is 3, I go up just 1. I went up 1. When x is 2, I don't go up any. Y is 0. Y is how much I go up and down. Now, since this symbol right here did not say greater than equal, it just said greater than. It just says greater than, it doesn't say equal. Same argument if it said less than. If it doesn't say equal, you dash the line. You dash the line. The points on the line have the property that x minus y equals 2. But we don't want x minus y to equal 2. We just want it to be greater than 2. Now, you need to test some values. Either all the points below and to the right of my dashed line have the property that x minus y is bigger than 2. That is, either all the points down here or all the points above that line satisfy x minus y is bigger than 2. Now how do we tell which half to shade in? It's either one half, either all the points on one half work and none of the points in the other half work. It's always one half all the points work and the other half of their division line do not work. So we pick a point. It's clear to me what half 0, 0 is on. So we are going to test 0, 0. Is x, now remember x is 0 and y is 0. Is x minus y bigger than 2? Is 0 bigger than 2? Answer is no, it's not. So shade in the half that does not include 0, 0. All the points I'm shading in have the property, now remember every point has an x and a y value. All the points I'm shading in have the property that if you do x minus y, you'll get bigger than 2. Okay, now, fill out the space. I erase this work. I do the same thing for the next line, or the next inequality. Y is less than negative 2x plus 3. Except first, we graph their equality. Y is equal to negative 2x plus 3. How do you get y? You multiply x by negative 2, then you add 3. So you pick some x values, 0, negative 1, 1. When you multiply 0 by negative 2, you get 0. Add 3, you get 3. When you negative 2 by negative 1, you get 2. You add 3, you get 5. Excuse me a moment. multiply -2 by 1, you get -2. You add 3, you get +1. So it was a good idea to plot 3 points. Well, the first point is 0, 3. That's right here. The next point is -1, 5. That's right here. The third point is 1, 1. The scale obviously is off a little bit, but that's right there. And what happens when you don't use graph paper, but it's the concept that matters. So here it is. And since it doesn't say equal, it says less than, it doesn't say less than equal, we dash the line. In fact, let's use a different color. You dash the line. Let me dash it. So this green line separated the whiteboard into 2 parts. One on one side of the line, one on the other side of the line. Again, it's very clear which half the origin 0, 0 is on. Remember, either all the points on one side were, all the points on one side were, and no points on the other side were. We just need to find the side that works. So letters test 0, 0. X is 0, y is 0. Is y less than -2 times x plus 3? That's 0 plus 3 is 3. Is 0 less than 3? And the answer is, of course it is. So we shade in the half that contains the origin. We shade this. And we're looking for overlapping. We're looking to see where the black lines are intersecting the green lines. The answer is in here. And we put a big S in here denoting the solution set. There it is. Some teachers, especially when there's 3 lines, I support this. You shade away the bad points. That way, the area that's clear, the area that has no lines, that's the answer. Let's try another one. Do this one. Suppose you know that x plus y is equal to 4 and 2x minus y is 6. And I meant to say this is greater than equal, and the bottom one is less than equal. Let's just make it less than. So we're going to graph this. So let's first do the first one, so let's do their inequality. Let's graph their equality. Let's graph equality. Then we deal with their inequality. X plus y equals 4. Well, I want 2 numbers that add up to 4. Understand what the problem is asking. Students, did they think this is painful? I want 2 numbers that add up to 4. Oh, you mean like 0 and 4 and 1 and 3 and 2 and 2? My response is, yeah, absolutely. I want 2 numbers that add up to 4. One is called x and one is called y. One, 2, 3, 4, 5, 6, etc. One, 2, 3, 4. Okay, 0, 4 is right on the y-axis, right at 4. 1, 3, you go up to 1 on the x, and then you go up 3. X is 2, y is 2. Go to 2 under x, and then go up 2. There it is. And before you draw the line, you look at the symbol, and since it does say equal, you draw a solid line. It says greater than or equal to. Okay, there it is. Now we need to decide which side to shade in. So, it's clear to me what half of the line the origin is in. The only time you really wouldn't use the origin is if it crosses the origin. The line crosses the origin. The line crosses the origin. What side of the line is the origin on? It's not on any side. It's on the line. Okay, so x plus y is greater than or equal to 4, and x and y is 0. X plus y is greater than or equal to 4. 0 is greater than or equal to 4, or of course it's not. 0 is smaller than 4. So we shade in the half that does not include the origin. Either it's all the points on her side, or it's none of the points on that side. Alright, so that's done for the first line, for the first inequality. Now let's deal with the second inequality by graphing their equality. And you go to line number 2 and just graph 2x minus y is equal to 6. Every point has an x and a y value. If you double the x value and you take away the y value, you're supposed to get 6. Well, if this was 10, if 2x were 10, for example, I know that 10 minus 4 is 6. So y is 4, and so 2x must be 10. 2 times 5 is 10, because x is 5. Okay, if y is 0, then 2x must be 6. If y is 0, then 2x must be 6. Well, if 2 times x is 6, x is 3. 2 times 3 is 6. If y is negative 2, 2x minus a negative 2 is 6. That means 2x plus 2 is 6. That should be 4. 4 plus 2 is 6. 2x is 4. 2 times some number is 4. I know that number like I know my name. It's 2. Okay, so let us plot these points, and then we'll decide which half to shade in. X is 5, y is 4. Here's 5. You go up to 4. 3, 0. That's right on the x-axis. It's 3. 2, negative 2. You go to 2, and you go down 1, 2. Right here. And since it does not have the equality, it says less than, we draw a dotted line. I think it's clear which half of the line the origin is on. So we will test the origin. If the origin is on a line, pick a point where you know what half of the line it's on. Okay, 2 times x minus y is 6. Excuse me, is less than 6. 2 times 0, 0. Minus 0, that less than 6. Is 0 less than 6? You better believe it. So I shade in the half that contains the origin. And I don't let the black line bother me at all. I'm just dealing with the green line. I'm shading in all the points less than 0. Let me erase this over here first. A lot of students, they get sloppy in how they do it because they don't start drawing these shaded lines starting from the line. They start from here. And of course, they're going to go a little bit past the line, a little bit before the line, a little bit past, again a little bit past, a little bit short. That's not good. Look how nice mine is. And I'm very sloppy in math, in my graphs. Why? Why am I being good this time? Because I'm starting on the line. I put my marker on the line. On the line. How can I ever fall short of the line or go beyond the line? I'm starting right on the line. And I never have problems. Okay. I'm looking for where the two graphs intersect. Okay? And it seems like they intersect on the top in that V shape on top. That area that looks like a V. It's right there. That's the solution. You take any point here. You take any of these points. The x value plus the y value will be greater than or equal to 4. And if you double the x and you take away the y value, you'll have less than 6. Now, the solution includes these points right here. They include these points right here. They do not include the points on that line. They do not include them. That's why we dashed them. Okay. This is an okay method when you have two graphs or two inequalities. But when you start having 3 and 4 inequalities, it's going to start being messy. Suppose you were asked to graph this. X is greater than or equal to 0. Y is greater than or equal to 0. 2x plus 4y is less than 8, less than equal to 8. And 3x minus 6y is bigger than 6. Suppose you were asked to graph this. Well, basically, these are 4 inequalities. Let's just say, for argument's sake, one of the lines looks like this, and you shade it this way. And the second line looks like this, and you shade it that way. And you shade it that way. And the third line looks like this, and you shade it, and it's to be shaded this way. And yet, our fourth line goes like this, and it is shaded this way. Where do the 4 lines intersect? And I'm not even going to touch this one. It's not clear. At least it's not clear to me. I wouldn't dare do it this way. You really should shade away the bad points. Well, though, you might say, well, I know what that means. That means x is not less than 0. That is nothing to the left. Because all those points have x is less than 0. And if y is greater than or equal to 0, then y can't be negative. That removes quadrants 3 and 4. We're just in quadrant 1. But I really believe we should get into the habit with this problem, when we have more than 2 lines, to shade away the bad points. Okay, x is greater than or equal to 0. If you were to graph the line, the equality, if you were to graph the line x equals 0, if you were to graph the line x equals 0, well, that's just the y-axis. All the points on the y-axis have x equals 0. And since it says greater than or equal, the solid line here is x equals 0. Now, here's our first case where 0, 0 is on the line. So we pick any other point. I'll pick this point right here, 1, 0. That's going to be my test point. Test it. I am going to test 1, 0. Is x, which is 1, is that greater than or equal to 0? The answer is yes. We want to include that point. That's a good point. But since we have 4 different lines, oh my, I am going to shade away the bad points. We shade away the bad points. Okay. So that line is done. That line is done. The next line, y equals 0. Excuse me, y is greater than or equal to 0. Well, we do the equality, y equals 0. Well, you should know that y equals 0 is the x-axis. Every point on the x-axis have something in common. Y is 0. Okay, and since it said greater than or equal to, the given problem said greater than or equal to, drawing a solid line was correct. Now, it crosses the origins. I'm not going to try 0, 0. In fact, it crosses 1, 0. I won't try that. I'll pick another point. Maybe this point, 1, 1, 1, 0, 1. Anything where it's not on the line, and you know if it's above the line or below it. I'm going to test 1, 1. Okay, remember, x is 1, y is 1. Is y greater than or equal to 0? The answer is, of course it is. So I want to keep all the points above the y-axis, above the x-axis. Which means I am going to shade away the bad points. I am shading away the bad points. I'm shading these away. And if you notice, the only thing that survived so far is quadrant 1. That's exactly what I said, x greater than or equal to 0 and y greater than or equal to 0 gives us. Now we go to the third line. 2x plus 4y. We're going to practice, or we're going to solve it equaling these and graph the line. Probably the best way of doing this is to do the x and y intercept. If x is 0, then it's as if this is not here. So 4 times some number is 8. Well, I know that. It's 2. Okay, now y is 0. So the 2x is back, but y is 0. Well, 4 times 0 is 0, and 2x plus 0 is just 2x. That is, it's as if this is not here. 2x equals 8. Y is 0. 2x equals 8. 2 times some number is 8. Well, I know that number. It's 4. Okay, 2 points determine a line. It crosses at 0, 2, 1, 2, and it crosses the x-axis at 4. Crosses right at 4. And it does say equal. It does say equal. So I am going to draw a solid line. And here it is. Here is my line. I want to test the point. I think it's clear that 0, 0 is below that line. So 2 times x plus 4 times y, is that less than 8? 0 plus 0 is 0. Is that less than or equal to 8? Yes, it is. So that's a good point. The origin is good. I'm going to shade opposite. I'm going to shade away the bad points. As of right now, our answer is this little triangular region that in this first quadrant. Right now, that is the answer. Okay. Let us graph the fourth and last line, or inequality. First, we draw the line. 3x minus 6y equals 0. Equals 6. X and y. Well, if y is 0, it's as if the 6y is not there. So 3 times x equals 6. Call x what number? 3 times what number is 6? Oh, 2. Now, let x be 0. So this is as if it's not there. So you have negative 6y equals 6. Negative 6 times some number is 6. You all know that 6 times 1 is 6. So please don't tell me that the answer is 1. Because that isn't 6. It's negative 6. So it's negative 1. Y is negative 1. We cross the x-axis at 2. And the y-axis, we cross at negative 1. So here is my new line. Here is my new line. And then we test some point. We are going to test this origin. The origin is right above it. Right above this new line. 3 times x minus 6 times y. Is that, is that bigger than 6? Is 0 bigger than or equal to 6? The answer is no, it's not. So shade away from the origin. Shade away from the origin. Shade this way. Now this little triangular region right here. This little triangular region, wave by to it, because it's getting crossed out. It is getting crossed out. Now, especially if when you shade, you start from the line and draw. You start from the line and draw. You're going to get a really nice looking, clean area. Look at how nice it looks. I've never seen anything more beautiful in my life. There is your answer. Nice and clean. The answer is the empty space. If you want, even when you just have 2 equations, you might want to use this technique. Shade away the bad points. You don't want to look to see where 4 lines are overlapping. You're going to have to wear glasses shortly after you do a few of these. I'm just looking for where it's clean, where there's no writing. Okay, so there's that problem. If you have if you have 3 or more lines, oh boy, you really should shade away the bad points. If your teacher says shade away the good points, basically you tell your teacher tough. I'm shading away the bad points, and I'm writing a big S in my solution space. I'm saying, here's my answer. It's not so much how you graph, it's what really counts is what answer you get. As long as you don't make a mistake, as long as you get the right answer, you should get full credit. that involve absolute values. Suppose you're told that the absolute value of x is less than or equal to 2, and that y is bigger than x. Okay. First thing you have to understand is what that means. Absolute value is less than or equal to 2. Well, I like you to think distances. Remember, x is the same as x minus 0, less than or equal to 2. I mean, here's a number line. Here's 0. The distance between 0 and x is my mandatory minus sign. The distance between 0 and x is less than 2. So x cannot be more than 2 to the right. It cannot be more than 2 to the left. It can be exactly 2 because it equals. So I can be in between negative 2 and 2. X can be in between negative 2 and 2, including the endpoints. Okay, here's negative 2, and here's positive 2. And I can be in between. And including 2 and negative 2. That's a draw a solid line. I have to be in between. That means I don't want to be outside. Look at how beautiful it looks. Where I can be, exception of the y-axis being there, is perfectly clear. In fact, I'm going to draw all of them by drawing the opposite. Okay, that's the first graph. Now we're going to go and look at the second one. The second one says y is bigger than x. So, of course, we're going to graph y equal x. Y and x are equal. 0, 0, 1, 1, 2, 2. Y and x equal the same. So since it doesn't say equal, it says just greater than, I draw my dashed line. Now, which half do I include? So we test 0, 0. X is 0 and y is 0. Is 0 bigger than, oh, what am I saying? We can't use 0, 0 because it's on the line. So I pick another point. I'm going to pick 1, 0. I'm going to pick 1, 0. No, that's not 1, 0. I'm going to take 0, 1. Sorry. Is the y value bigger than the x value? That's the $64,000 question. The y value, is it bigger than x value? Yes, it is. So I do not shade in the half that includes that. Nice, good point, 0, 1. I shade the other half. Is exactly where you have clean space and solid lines. That is, the answer, the solution space is in here, including that piece, sorry. The solution space is there. Should have just drawn a bigger S. The solution space is there. And it includes all of these points, but not the points on that line. Not the points on that line, because it was dotted or dashed. Okay, much cleaner to draw their graphs opposite than what you want. That is, shade away the bad points. That way you don't have to look for overlapping. I do have one comment to make. Although this is a pretty big triangular region here, make sure that when you go to shade away, you go here and then there and then there. Don't jump too far. Don't jump too far. Because you have that little triangular region right here that was supposed to be shaded away. So make sure you don't miss that. Okay, this finishes the section on graphing inequalities. System of inequalities. Good luck with it.